Our next speaker from the Cayman Islands, Alex Alexandrov from Velas. He will talk about the blockchain ecosystem and the future of money. Alex, the stage is yours. Wonderful.
You hear me? Yeah, there we go. That's perfect. Awesome. Thank you. Hi, everybody. It's super bright up here. So my name's Alex. I'm from, I guess, Cayman Islands now. Originally from Vancouver, Canada. That's where I spend most of my life. Yeah, thanks. Canadian people here. Awesome. Yeah, right. More like raptors nowadays. So my background, I started in crypto in around 2011. Got really interested into it because I was a Forex trader at the time and just saw the opportunity to trade more fairly and understood that these are like real people that are trading things. And, it led me to starting a company called Coinpayments. We've become a quite significant player in the space now. We're, at this point, the largest altcoin payment processor in the world. So we're really excited to have that side of business, which let us see a lot of developments in the space as it took place. So all the coins that have been coming out, we had to run them, we had to install them, we had to maintain them, and we had to kind of learn how to work with all these different cryptocurrencies over the years that have come and gone. So our team is quite, advanced when it comes to analyzing blockchains, setting them up, running the nodes, and things like that. So without further ado, let me jump into what we decided to do.
Velas is a blockchain platform for secure, interoperable, and extremely scalable transactions. Velas is a virtual expanding, learning, autonomous system powered by swarms of single-cell artificial intuition specimens, continuously powering the blockchain consensus and electing appropriate delegated proof of stake nodes based on what's best for the network. Velas Artificial Intelligence elects block producers based on performance, dependability, and amount staked, while also optimizing network parameters such as block production speed, allowing the network to automatically slow down or accelerate, making it capable of processing up to 30,000 transactions per second. Artificial intelligence on the Velas platform also reduces the cost of consensus, motivating participants of the network to be reliably present and active in the network, maximizing relevant scores and rewards, while also optimizing network parameters, resulting in an enhanced network without issues, such as the 51% attack and nothing at stake problem. To explore all the features and learn how Velas uses neural networks to determine node score rating, block producers, and much more, check velas.com.
Cool. So that was a quick little video of explaining. I don't know if you could hear. You guys hear it really well at all? Okay, awesome. I guess it's just here. So the idea is to create a blockchain that employs artificial intuition. Now, by show of hands, who knows what artificial intuition is? I know you've heard about AI. One? Okay, all right, so I'll dive into that a little bit. So the artificial intelligence is, machine learning, processing significant amount of data to understand the patterns and learn how to navigate them and things like that, which takes an enormous computation power and takes a lot of data. Artificial intuition is a little bit different in the sense that it's a little bit more self-guided. So think of single-cell bacteria. For example, when single-cell bacteria is born, it doesn't really have eyes as senses. It just has some receptacles where it allows it to navigate through the world. The parents don't really teach it what to do. They don't have schools. They don't really have any kind of education system. So they're just born with what we call an intuition to know how to navigate the world. And that comes from, billions of years of evolution, which is basically their neural network or DNA in real life, which allows it to know how to find food and avoid poison, mate, and pass down its DNA and kind of evolve further with its own receptacles that are needed for survival and the daily tasks. Now, that said, I'll come back to it. With blockchain still having some problems in the world that we've identified, like some of the things, like as you can see here, many of the blockchains right now have centralization issues. So what that is, we are either at mining or proof of stake always seems to lead to this pyramid type of scenario where over time less and less people are mining it, or they're kind of aggregating into these bigger and bigger mining pools that are basically leading to the same outcome. With the proof of stake, it is a little bit better in the sense of like more people can participate and produce blocks by holding coins, but after a while it still has its own flaws because who are these people holding the coins, and is the person, like the previous speaker was saying, is the person with the more money, is he necessarily making the better decisions. Just because he has more money, is that really, it's more of like a philosophical issue at that point. So you got to realize that, we have to decentralize it so that the network kind of takes care of itself. And if we have people making decisions, it's great. It's democracy. It's amazing. But people are not always well informed and also make good decisions. And I mean, I'm not for tyranny, but at the same time, there's got to be a third way to solve this problem. And one of the best solutions that we thought in the network that could be implemented is to allow artificial intuition to guide the network selection. So it allows ranking of people who are contributing to the network, and they give a score. And then once you get a score and you provide good hardware and you're providing good uptime and good computation power to the network will give you a score, plus where you are geographically located. It will take into consideration how much coin you have as well, because it's part of your commitment to the network as well, but it's going to be just one factor out of many. And the artificial intelligence will then analyze it and give you a score, and if you fit all the criteria, it will make you a block producer. However, at any point, if somebody provides a better quality for the network based on the score that it provided them, you'll basically lose your spot and it'll go to somebody else. And that will be decided by artificial intuition, not by people, but by what's actually best truly for the network without any bias or any kind of, he said, she said type situations where it's clear and transparent, and yet it is decided entirely by the process that runs and understands the network better than anyone else can, the network itself. So the next slide here. So one of the cool things about this project and why we got excited about it is we had to start in nature to understand how can we decentralize artificial intuition. There's a lot of artificial intelligence processes systems out there. Google has one, Facebook has one, Apple, so on and so forth. But these are like generally really big computation farms, and they process a lot of data, and they work for specific tasks, which works perfectly for their business model. But if somebody entrusted somebody to run AI, to run the blockchain, eventually it will be a centralization issue we're trying to get away from. So the only way to solve that is to decentralize the AI, which there hasn't been technology that's come out that really do that yet. So we had to reinvent everything from the start. So by analyzing nature, and I'll get into that in the slide to kind of visualize how this works. So I really am terrible at following slides, by the way, just to give you an idea. So in order to mimic nature, and you're looking at bacteria, single-cell organisms, how do they survive? How do they really strive? How do they learn? What happens is, if you put them in an environment that's hostile, they will have, two outcomes. They will either get through it or they will die. On their own, generally, they might not make a hostile environment and they might survive. But in the groups, some of them will evolve around the situation and teach the others on how to do it, and teach it by passing their DNA, which is basically the precursor to evolution, which allows survival of the fittest and allows the information to be passed down genetically. So in the computer world, not to say that they're living things, but it's very similar behavior we observe on the computer. So when you create these, what we call them single cell entities, it's taken us, probably over the last year, most of the time last year was actually to develop the first 27, which don't have time to get into right now, but if somebody's interested, I will get in a discussion. To create the first 27 through conditions of survival, those are the ones that are left that are constantly able to find food, discover poison, and compete with others and understand the criteria of the network that are thrown at them. Now, we then scale them up and made 100. So we have a silo of 100 in each node producing block on their computer that they're running. In that 100, they have to reach a consensus of 80-20%. So basically 80% has to be right, 20% can be wrong. Every time that consensus is not reached on a decision making on what parameters need to be adjusted on the network, the silo mutates. Now, that happens on the level of a silo, and it also happens on a network level. And AI decides how many block producers there should be out there. And between each silo, it has to also reach consensus of 80-20, no matter how many there are. And if consensus is not reached, it goes by the back propagation method, and it basically pre-mutates them all again and reruns it, and the network reassesses itself to see what was the best setting currently available at the time where everything was reaching consensus. So essentially, it kind of pushes forward, and it always makes sure that things are working correctly as intended. Now, the evolution part of it takes place, and the losing segments that were in a silo that performed worse than the winners or the faster thinking and performing individual single cell entities, there's another AI that watches their permutation matrix, or basically analyzes their neural network inside their silo, because a human can't really analyze neural network and really understand what they're looking at. It's at this point is so complex it will actually get pretty insane. So you have another guy analyzing it and identifying which parameters, or we call them mutagens, in their artificial network, which is their neural net, are the main key features that allow them to win the race over the others. And what it does, it takes those pieces and merges that with the losers. So we don't delete the losers because we don't want to get rid of genetic variety. But what we want to do is we create a mix inside, which case it kind of mimics nature and improves them continuously through each evolution cycle, right? So to give you an example, this is Harvard Medical School experiment with a bacteria and resistance to antibiotics. So just to give you a visual idea how our nodes would work, this is probably the best example I could find. So what they've done here, they have a Petri dish, and on this Petri dish, it starts with 0, where there's no antibiotics. And they place bacteria on this Petri dish, and then they multiply by a factor of 10. So the first one has 1 time antibiotics. That one's 10 times more stronger, 100 times stronger, and 1,000 times stronger. Now, these bacteria are not trained to avoid they don't have any capacity to avoid antibiotics, so they have to survive, and see how they do it is very interesting. So what happens when it starts, they have to move towards the center. That's kind of like how the Petri dish is formed. So in order for them to survive, you have to keep pushing to the center from both sides. Now, let's see how this looks like. So here you see bacteria dropped on the side where there's no antibiotics, and shortly, a few days later, you see the first breakthrough. You see the first mutation that allows it to get to the antibiotics level where, it's 1 times higher versus 0 antibiotics. And more time goes by, and you see they keep evolving. What they're doing is they're evolving themselves, and then every time they break through it, they pass the DNA to the new generation to learn how to do that seamlessly and easily, allowing them to be antibiotics resistant. And shortly after just 11 days, they reach 1,000 time antibiotics resistant level without, too many issues. 11 days, this by itself is horrifying, by the way. But as an example to what we're doing, it's really cool because it demonstrates how single-cell bacteria working in groups can overcome any obstacle. And that's, to me, is an intuition example, less than intelligence, because these don't really communicate. They don't really store memory. They do that by evolving their features, which keeps the memory load in our system much lower. We don't have to process a lot of data. They just basically adjust their neural network. They don't keep their memory. They just know intuitively then how to deal with the problem they've already been facing with. So as you can see, the layout of how it progresses. So this is very similar to how the silos in our network will defend the network and work as a immune system to the blockchain itself. So when the attacker is trying to do a 51% attack, or is trying to do bad messaging, or any kind of issues on the network will respond with an actual autoimmune response to it. It will actually defend itself and protect itself from the vectors of attack. And the sooner it will learn from it, the faster it'll be completely, that vector of attack will become completely useless. So essentially, it learns from its own data sets, which are coming from the user's interaction, malicious or good, and allows it to improve itself constantly versus the traditional blockchains where we have to constantly do updates, upgrades, scalability things, and so on and so forth. Now, what's cool about our AI is that it's based on the same principles, which beyond that, also allow our blockchain to scale up to the size that it needs. So the AI can analyze the input data and say, okay, right now, somebody is doing a lot of sands, or doing a lot of smart contracts, or doing a lot of containers. Containers is something that's kind of cool that we did as well, that allows any coin to be deposited into Velas and be zipped around on a network in a container form, which is basically like a lightning solution for all coins on the blockchain. So there's no trust factor or issues. The idea for that came from the fact that we see a lot of blockchains having scalability problems, and targeting each one individually is kind of a nightmare job, and we've had to do it because we run Coinpayments and we support 1,350 coins, right? And we have 3 million users, so you can imagine the backload that we're dealing with. And that kind of led to the idea of why don't we just create a blockchain that kind of unifies everything like a glue and works seamlessly and then protects itself. And it sounds like a crazy idea, but we did it, and July 4th, we're going to be doing the token swap for our users natively on our system, and we're pretty excited to show it to the world and develop it further. Now, one of the cool things about this system that we'll run on is, you can tokenize anything, just like on Ethereum, just like on EOS, just like on any other coin. But you don't have to. You can take your existing tokens from the network that has scalability issues like Ethereum, for example, like, they can do like 21 transactions a second type thing. If that's an issue for your project, you just hop on Velas and just tokenize your system through our container system and zip around at 30,000 transactions a second with blocks every 2 seconds. And if the network detects that nobody's using it, it will switch from 2 seconds to 10 seconds to up to 2 minutes per block. So we don't actually creating empty blocks consistently. And it will also solve another issue, which I believe was a big one, is once you become a block producer, your incentive to maintain one has to be there as well, and maintain your position and continuously upgrade your hardware. Our system will reduce the reward because it will scale down the amount of blocks being produced and the rewards being produced by the block producers if the network activity goes down, which motivates the block producers to go out there, promote the network, promote the use, and increase the actual usability so that they can increase their reward. So it's actually a complete relationship there. I think I can keep going, but tell me. I know I'm out of time. Sorry.
I think it's better to take some question, don't
Okay,
you think?
sure. Sounds good.
Or you keep on talking and have no question? As you like.
There's a lot to cover in 20
choice,
minutes,
yeah?
so I'm just kind of like,
Do you prefer to talk and no questions?
Anybody have questions? I'm sure there's got to be some questions. All right.
So I try to understand, but...
Talk to the mic.
Yep.
Yeah, it's
okay.
very low, I know.
All right, so maybe it's a silly question, but the artificial intuition is defending the system. So I guess it has to have some set of conditions on which it's estimating whether the system is under attack or not. And so these conditions you're going to define, I guess, and also how do you make sure that someone doesn't take that set of conditions and builds a strategy that can take advantage of it, actually?
Yeah, it's a great question. So we don't really need to predefine it because it analyzes and sees what causes a threat on the network, which is its own living environment. So if it sees that somebody's doing something malicious that has an output that reduces some activity on the network, it will understand that it's malicious on its own. So we don't have to train it anything. So for example, if somebody's flooding the network with a lot of bad messages, right, which has happened in Bitcoin, and it raises the fees for everybody as a result of it, the network will just ban that person because they realize the usability goes down and the fees increases, which is actually bad for the ecosystem. So it will actually make that decision on itself because it knows it's bad for its own ecosystem. Just like bacteria, if you throw it in the area, right, and you put poison, they will hit it a few times and then they'll learn to avoid it.
So if it's reducing activity, that's considered negative. So basically, right. Some sort of activity going through the system is the measure of how alive it is, and that's what it's reacting to.
So they always have a race between each other, between silos, who discover blocks first, and the ones that win, the ones that create the best scenarios, their genetic code is passed to the other ones, right? Which is part of their parameters to always win and compete with the rest, and always have the best solution, and then pass down to the rest of the silos. So if there's anything that shows the results of the network going down in any way, in any aspect, it will detect that as a threat.
Sounds super cool. And how far are you into realizing this?
Alpha 1 is ready. We're launching Alpha 1 in June. Stage 1 is going to deploy, our target is October. And then we have, if you look at a white paper at velas.com, it explains every stage of rollout, but it's going to take a full year to go to full functionality of the network. Some of it has to do with the fact that we've done a lot of it in our labs, and real world doesn't always work like that. So at this point, we want to make sure that we have a robust and steady growing network with people going on and offline and turning these things off, and the nodes can replicate and work perfectly. So we're going to do it in stages by rolling out and running 4 master nodes at first to make sure that it never goes down. And then on stage 2, we'll let master nodes pick the signaling block producers with the right hardware that is sufficient enough to run it and start decentralizing. Stage 3 will remove the master nodes because at this point we know stability is achieved. And stage 4, it's a working product when we allow people to download the best artificial intuition segment silo and work on their projects, train it to like find the music to like or whatever, right? And then sell it back to the network as a contract to users to deploy. So you have smart contracts plus AI.
Cool. Yeah. Thanks. Thank you.
Okay, great. Yeah. One more question? Okay. So, thank you so much.
All right, thanks.
Thank you very much. Great. Okay. So, our next speaker, please applause.